Okay, is that up there? Awesome. Cool, okay, so thanks for coming out, everybody. Really appreciate it. So tonight we're going to talk about Docker, and especially in the context of continuous delivery. I was really excited when Sam offered to have me come in and talk about Docker here because I've spoken about Docker a lot before, but never really in the context of continuous delivery. And so I was able to kind of expand my presentation to get beyond the basics and talk about the parts of Docker that make it really exciting for me to use. So Docker is a really interesting technology, and we won't be able to get into all of it tonight. But my objective is to have us kind of cover the basics, cover a typical workflow so that you can understand how people are using Docker, and then talk about what it means for continuous delivery and wrap up with some tips on how you can get started using Docker yourself so that you can go and try it out tomorrow, or maybe even tonight. So first, a little bit about me. My name's Andrew Baker. I'm a software developer. I actually work for Sam, which is really funny. I took some time off from my last job, my consulting job last fall, to work on my own projects. And I got really lucky that one of those projects was doing an Introduction to Docker video tutorial with O'Reilly. So it's a 2-hour tutorial that takes you from the basics all the way to deploying code and infrastructure changes to your Dockerized apps in the cloud. It's also on O'Reilly's Safari service, so maybe your company subscribes to that. You can look at it on there for free. And I'm personally not one that normally buys videos, but if you think it could be helpful for you, you should send me an email and I can give you a discount code for it. But my blog and Twitter are also up there, and I try to keep up with the Docker stuff, so that's a good place to stay in touch too. But now I want to talk about you. So the first question I have is, it's good to get a feel for who in the room is doing development and who in the room is doing operations. So raise your hand if you would say you're more on the development side of IT. Okay, and ops? Okay, yeah, maybe 2/3 development, 1/3 ops. Cool. And how many people have tried doing the official online tutorial for Docker, the one that happens just in your browser? Okay, probably about a quarter of the room. And who has gone ahead and installed Docker on their computer? Okay, most of the room. And who has written a Docker file for their own application before? Okay, cool. Wow, awesome. So I think we're in the sweet spot for this talk. So hopefully everybody should get something out of it. So today we're going to start off trying to define exactly what is Docker, but we won't spend too much time doing that so that we can get to the more interesting stuff. We'll look through a workflow of how you would deploy software applications with and without Docker. We will take a step back and kind of look at Docker's origin story and where it's going as a company and as an open source project, because I think it's a really interesting story. We'll talk about what it's like to use Docker today, and talk about some of the new tools that are coming out that are from Docker and from third-party services that make it easier to integrate Docker into your organization. Then I'm going to wrap up by talking about, now that we've sort of explained Docker, what exactly it could mean for continuous delivery. And then I'm going to give you 5 quick tips that you should know before you start working with Docker yourself. And of course, we'll have some time for questions. So has anyone said this phrase to someone they work with before? I have. And if you're one of the operations people, you've probably heard a developer say this phrase to you, which might be even worse. So environment differences are one of the worst parts about doing software. It's the worst feeling when you've worked on something really hard and you think it's working great, and maybe it even went through your build pipeline and was looking good, only to blow up in production, and probably someone important is now very upset with you. And you two are trying to have a rational conversation about it, but you're both human beings, so there's probably some corner in the back of your brain that's wondering if it's your fault that this happened or not. And it's a really crummy situation. So for me, Docker is an interesting technology for lots of reasons, but as a developer, it is most compelling because it helps me solve this problem. The promise of Docker is build once, run anywhere. This idea that with the world of Docker and software containers, you have kind of this box that you, as the developer, can wire up exactly the way you want, and then once you package up that box, it should behave the exact same way everywhere you put it. And in my, I guess, 2.5 years of working with Docker so far, for the most part, it's held up. So I think they more or less deliver on this. So what is Docker exactly? When people first hear about Docker, they normally try to put it in a bucket of an existing technology that they already know about. So you may have think that it's like a virtualization tool like VMware or VirtualBox. You might compare it to a VM manager like Vagrant. You could think it's like a configuration management tool like Chef or Puppet or Ansible. Or maybe you've heard phrases like C groups, LXC, libvirt, Go, software containers. The truth is that Docker is really kind of in a category unto itself. And if you go to their website and ask them to tell you what Docker is, you get this, which says, Docker is an open platform for developers and sysadmins to build, ship, and run distributed applications, which is sort of helpful. I know that it's related to building and running applications, but a phrase like that still doesn't mean that much to me. So I prefer to think of Docker as occupying a spot on a spectrum. So this is a spectrum of techniques available to you as a developer or as an operations person for deploying an application to a server. So all the way on the left side of the spectrum are techniques that are less portable but have minimal additional overhead besides the work you need to do to put that application on that server. And obviously the epitome of this end of the spectrum is manual configuration. So when you get a new server that shows up in a box at your office, or if you spin up a new EC2 instance in Amazon Web Services, you have to gain access to that server, run all the commands you need to do to install the system level dependencies, install any supporting libraries for your software application, and then deploy the source code for your application itself. And this process is great because it's simple, but it is error prone, and if you have to take that same process to the next server, you have to spend just as much time doing it. So the conventional way to solve this problem for most of the past decade has been configuration management tools like Chef or Puppet. And these tools, you use their special configuration language to define the desired end state of your server. And then once you've done that, you can point that configuration management tool at any server you want, and it's going to set that server up exactly the way you want. So this is a big improvement over manual configuration, but it still takes time to apply all of these Puppet files and cookbooks and Ansible playbooks every time you spin up a new server. So all the way on the right side of the spectrum, we have techniques that are most portable but have lots of overhead. And here's where traditional virtual machines lie. So some organizations these days, if they're deploying their app on Amazon Web Services, they might have their build process actually create an Amazon machine image and then use that to do their deployments. And when you do that, you are building a complete virtual machine, something that thinks it's its own computer, and you're wiring up everything inside that exactly the way you want, and you're going to put it on Amazon and tell it to behave like a regular virtual machine. And so this technique is great because you know that that virtual machine is going to work exactly the way you intend it to work because it thinks that it's its own complete isolated environment. But it has lots of overhead, right? Virtual machines are not efficient because to run them, we have to virtualize hardware for our virtual machine to consume. And they take a long time to boot up, and the disk images are really big because it's an entire hard drive that you would need to support a whole computer. So for me, Docker occupies a sweet spot on the spectrum, where you get most of the benefits of isolation of traditional virtual machines, but at a fraction of the computing overhead. And if you've been to Docker.com before, you've probably seen some diagrams like these, which explain how it works. So with a traditional virtual machine setup, we've got our server hardware at the bottom, then we have a host operating system, and then that middle layer there, that gray box, is, it might be hard to see on the screen there, but that's our hypervisor layer. So that's VirtualBox or VMware, which is taking the computing resources of our host operating system and using them to create what looks like fake hardware that our guest operating systems then consume. And then on top of that, we install our binaries and libraries, and we install our application source code. So when you're using software containers, the stack looks a little thinner. You still got your server hardware at the bottom and the host operating system, but instead of that hypervisor layer, you're using the Docker engine instead. And you'll notice that on top of that, we don't need to run a duplicate guest operating system. Docker is not the first technology to use software containers. And if you want to get into the low-level Linux details, there's lots of information out there on the web. But if you're not interested in that, all you really need to know is that Docker is smart enough to leverage the components of the host operating system to provide what looks like an isolated guest operating system for your application. And I think actually one of the beauties of Docker is that you don't need to be a Linux expert to use it. If you did, I definitely would not be standing here talking about it here before you today. So that's kind of the rough overview on exactly what Docker is. To see how people actually deploy their applications using Docker, let's step through a couple workflows of how it happens. So we'll start off with a traditional workflow of how you would deploy your software application without Docker. So in this diagram, we have a developer's machine all the way on the left, a build server in the middle, and then we have our production environment all the way on the right. And the production environment is 2 boxes because we would probably be running our database on a separate host than the rest of our stack. And most of my background is as a Python developer, so this particular application is a Django application, but all the rest of the components should be familiar to people: Postgres, Nginx, Redis, and of course the Django application could be swapped out for anything else. So when a developer has new code, the first thing they would do is push it up to our Git repository. Maybe it's GitHub, maybe it's an internal Git server. And then our Git repository updates probably the latest commit to our master branch as the specific commit that was just created by our developer. And once that happens, as most people are probably familiar with, the build server jumps into action, right? So the build server will pull down the latest code, run our test suite on it, and then after that, if everything looks good, it will send a little green dot back to GitHub and say, hey, everything on this commit looks awesome. And if it's a pull request, it'll say this pull request is safe to merge. And then after that, someone somehow will decide that it's time to deploy. If you're doing continuous deployments, then maybe the build server's green box was all you needed for your automated systems to take that code to production. Maybe you have a system where you're using a configuration management tool to deploy every once in a while, but somehow eventually someone decides that code is ready for action, and that code gets pulled down onto the production servers. You update the Git repositories, the Git clones that are on that production server, restart your web services, your whole stack, and then everything should be looking good. So that's kind of a typical workflow. You might have configuration management tools to help you. You might have a different build stack, but that's kind of the basics of where we're coming from. With Docker, the diagram already looks a little different. You'll see that we have this extra box in the top right, which is the Docker registry, which we'll talk about in a second. And you'll also notice that all of our processes are running inside little boxes on our developer's machine. That's because a rule of thumb in the world of Docker is you want to have 1 process per container. So for each process that you need to run to emulate your stack, you're going to have a container running that process on every machine that you want to run your application on. And you'll also notice that in our previous example, the developer was only running the application server, the Django server, and the database. But now it's much, much easier using Docker for them to run their whole stack. So once our developer decides that they have some new code that they'd like to push up to production, they still send it to the Git server, just like they did before, and our build server still leaps into action, but things are a little bit different in the build process this time. So when the build server pulls down the latest code, it's actually going to create its own Docker containers from that latest snapshot of the code, run our whole test suite, and again, because we're using Docker, it's much easier for us to replicate every component in our stack. So the build server, too, can use all of the components that we would have in our production stack. And then once the build server is done, it's still going to send a green box it's still going to send a green box back to GitHub saying everything looked good on this commit. But it's also going to create a new artifact from that build. And that artifact is called a Docker image. And that Docker image gets pushed up to a Docker registry. So the Docker registry, you can kind of think about it like a Git server, a Git remote, where it's the way that you can store your Docker images in a separate place so that you can move them down onto any other environment you want to run them in. And there is this thing called the Docker Hub, which is sort of the official Docker registry that most people use for their open source Docker work. But all the code that runs the Docker Hub is open source so that you can run your own internal Docker registry if you don't want your application source code getting out to the world. So this Docker image is not just the latest snapshot of our source code, but it's also a complete snapshot of our source code with the entire environment that it ran in. So you can have much greater confidence that when we take this latest code to production, it's going to behave the exact same way it did on our build server because it's running in the exact same kind of environment. So then eventually someone decides to flip the switch and take our new code to production, and we still have a container running for each process, a box for each circle on that chart. But instead of pulling down the latest code from GitHub, we pull down the latest fully baked, complete, isolated Docker image from our Docker registry. And so this is the real power of Docker, is the kind of the knowledge and the confidence that the way that your application ran here and the environment that it ran in will be the exact same environment that it runs in for every step in your build process. So one important distinction to make, which is really hard for newcomers to Docker, is the difference between containers and images. I haven't found a good way to explain it to people yet, other than you just digging into a Docker tutorial and working with it yourself. But sort of the rule of thumb, shorthand you can keep in mind is that containers are how you run your application, and images are how you store your application. So a container is what you need to create every time you want to run your application in any environment, whether it's on your development machine, the build server, the production server. A Docker image is how you take changes in between those environments, how you move changes in between those environments. So like you saw on the last slide, the artifact from our build process was a new Docker image, which was a snapshot of what our source code looked like in a very specific Docker environment. So when you start working with Docker and you're trying to bring it to your own applications, the first thing sorry, I'll take questions at the end if that's all right.
Okay.
Thanks, man. The first thing you'll create is a Docker file. So a Docker file is essentially an extra file that lives alongside your source code, which tells Docker how it should create that image for your application. So if you can see this one here, it's just sort of a pared down example of how you might install how you might install a MongoDB server in a Docker image. So every Docker file has a special command at the top called a from command, which specifies what base image that image should build from. And those base images, most of the time, are just raw Linux distributions. So in this case, we're just taking a raw Ubuntu installation and then doing all of our work on top of that. But it doesn't have to be. So after that, even if you haven't seen a Docker file before, the syntax should be pretty easy to understand. Sometimes people just sort of call them glorified bash scripts because they're pretty straightforward. You use this run command to specify every command you want to run inside your containers. And then at the end of it, you specify a couple extra special commands to tell Docker which port it should expose from this container, and also what command should be the default command within that container. And so at the end of this process, at the end of your build process, whether you're running it on your development machine or on that build server on our chart a couple slides ago, this is the sort of the map that Docker uses to create that fully baked image from your application source code. Now, one of the really cool things about Docker is that you don't have to start just straight from a plain vanilla Linux distribution. You can use these things called the Docker library images. So the Docker library is essentially a collection of base images on the Docker Hub, which have already been configured with a lot of the programming languages, server appliances, and other tools that you will probably use in your stack. And it's amazing how many of them there are now. When they started out making these, they were just doing Python and Ruby, Java, just hitting the big programming languages. But now they've got them for Nginx, Postgres, MySQL, Memcached, Redis, pretty much any appliance you could imagine using with your stack. There's a good chance that someone has probably already done the work to make that appliance work with Docker for you. So when you start working with Docker yourself, you should definitely look at these official library images because they can save you a lot of time going from your raw application into a complete Dockerized stack. So I want to shift gears for a little bit away from the technical details and talk a little bit about where Docker came from and where it's going. And then we'll talk about some interesting tools that I think are important for people to use when they're using Docker today. So Docker had a pretty cool origin story, if you don't know it. It started off as a side project at this company called .cloud. And if you hadn't heard of .cloud before, .cloud essentially ran a platform as a service business. People would often mention them in the same breath as Heroku, where you would just provide .cloud your raw source code, and then they would figure out everything else that needs to happen to run your application in their cloud. And .cloud was never as successful as Heroku, and so it's really funny actually. There's a New York Times piece about Docker a couple months ago where they interview the current CEO, and he says yeah, we were on the brink of going out of business right before we open sourced this Docker thing, and we weren't really sure what was going to happen with it. But clearly it worked out well for him. So at PyCon in 2013, Solomon Hykes, who's the current Docker CTO, he open sourced the Docker project, and things started happening really, really quickly after that. A lot of people are probably here because Docker has such buzz around it that you are really curious. That's how I got into it. And over the course of 2013 and 2014, Docker just continued to build all this momentum, enough so that DocCloud actually changed its entire business to be around Docker. So now they're called Docker Inc., not DocCloud anymore, and they actually sold off their platform as a service business to some other German company, I think. So it's a really cool story of how essentially they were trying to compete as a platform as a service, and they were almost going to go out of business because they weren't competing very well. And they decided to take essentially the technology that was the secret sauce that makes it easy to run so many different applications in this multi-tenant environment, and they gave it to the world for free, and now they're building a business around that, which is just nuts to me. So it's a truly unique story. So this was a tweet that came out from DockerCon in 2014 of all the different partners that are working with Docker now. And it might be hard to see from the back, but there's a chance that you will find a lot of familiar logos on this chart. It was really interesting seeing Docker evolve over the course of 2014 because it seemed like for a while, every week there was a new announcement of some big entity in tech is getting, wants to make sure that they can work with Docker. So the Linux distributions themselves were the first to jump on so that you can install Docker directly from their package managers. But you'll see the configuration management tools are on there, the big data tools, of course all the orchestration projects that have come up around Docker, those official repositories, like I was mentioning, that list has grown so much. And of course all the ways that you can deploy Docker applications to the cloud, which we'll talk more about in a second. So when you are thinking about bringing Docker to your business, and if maybe you tried using Docker before and it didn't really quite stick, you should definitely check to see which existing components in your stack have added Docker integration since then, which could make it easier for you to get started. This is a fun slide that I always like to include when I'm talking around DC. This is a chart of when Docker meetup groups were founded around the country and around the world. And the blue dots here that go along sort of the lower side are the US, and the purple dots are international. And we are right here in the middle, Washington, DC. So we were actually before Austin, which I think is pretty cool. But you won't believe that we were behind St. Louis. I don't know how that happened. So I've gone to a lot of the Docker DC meetups, and it's a really cool group. So you should definitely join us if you think that Docker is going to be a thing that you work with often. So of course, there are tons and tons of open source projects that have sprung up all around Docker. One of the big ones early on was called Fig, which was written by a couple British guys and made it easier to run multiple containers at once. So if we were going to run that stack from our chart earlier on our development machine of our Django application and the Postgres database and the Nginx server and the Redis server, Fig was a tool that made it much easier to run all those containers at once and made it easy to start and stop your development. And it was so successful that it actually has become, they were acquired by Docker, and it has become an official part of the Docker toolchain, and it's been rebranded as this tool called DockerCompose. But there are lots of other open source projects that have sprung up too. So there were a lot early on that were focused around running your own platform as a service, because that is what Docker was doing at DocCloud before they pivoted. So the three big projects that people normally talk about for that are called Doku, Deis, and Flynn. And if you, I could definitely imagine a situation if I was still working at my old consulting job. At some of the big organizations we would work in sometimes, it was a real pain to get someone to give us a demo server. And I understand why, because demo servers suck to maintain if you're an ops person. But I thought it could be really fun to try using one of these platform as a service projects based on Docker to basically just create this situation where developers can get new demo machines whenever they want, and you can probably set some sort of rule to cull those machines whenever they're not being used or when they've been sitting around for a long time, and just totally let Docker handle that process for you, which I think would be awesome. There are lots of other ones. One that I wanted to mention because I thought it would be particularly relevant for this group are the continuous integration services. So most continuous integration services that are out there right now use virtual machines to do your test suite. So when you push new code up to Travis or Circle CI or something, they will spin up a virtual machine, and then they'll run your whole test suite and then report back to GitHub. Docker containers are a new way for them to do their jobs more efficiently. because containers start and stop in the blink of an eye. They are much, much faster to start up than virtual machines. And so, and of course, they take less computing overhead than virtual machines. So that makes it cheaper for the continuous integration services to do their job, which is all great for them. But for me, the reason why I like how Docker is getting involved in CI is because of how it helps those builds go much faster. And you should look, if you're using something like Travis or Circle CI, they all have their build counters, right? But I would bet that for most of them, the counter doesn't start until the VM has finished booting. And that's a surprisingly long time on some of these services, especially if it's like peak development time during the day in the afternoon when everybody's pushing up their code. So one open source project that is doing Docker straight from the beginning is called Drone. And this is they have their open source, the project that does the continuous integration is fully open source, but they also have a hosted version if you want to pay for that. And the other big continuous integration services are now starting to jump on the Docker bandwagon. So on Travis now, I don't know if it's an officially supported feature or if it's a beta feature, but I think if you basically specify sudo :false in your travis.yaml file, it will have your build run in a Docker container instead of a virtual machine, and you'll get to see that speed increases on your builds going through. Which, you know, I'm an impatient person, so faster builds is always something that I'm looking to achieve. This is also one of my favorite things about Docker is it makes it easier for me to use dependency-heavy utilities. So in my Docker tutorial, I wanted to find a fun way for students to make their first Docker containers, and I came across this project, which is called Gifify, or Gifify, depending on which philosophy you adhere to. It looks like a really, really cool tool to make GIFs, but it has a lot of dependencies. So first off, it's a node tool. So not everybody has node installed on their machines or NPM. And after you install this tool, you have to install 3 other system-level dependencies. You have to install FFmpeg. You have to install convert, which is some sort of image magic, utility. And then you have to install a fork of some other repository called Gifsicle. And I don't know, that was a lot of work just to make a GIF from my command line out of a movie file. But then I saw that some kind soul out there on the internet had already created a Docker image for this all on his own. And so all I needed to do was run one command saying Docker run this guy's image name and then point it to the movie file that I want to make a GIF out of. And then my Docker client on my machine would reach out, pull down that image, which already has everything installed on it that I need, run everything that needs to happen, and then pop out the GIF right there. So this is one area where I'm really excited to see how Docker catches on, where maybe you aren't going to use Docker in production to actually run your software application, but it could still be really useful for running these sort of one-off development tools that you only use occasionally. And so I'm hoping that eventually someone's going to create like a package manager essentially for these Dockerized command line tools, sort of like homebrew for Docker. If anyone is looking for open source fame, I think that is one route you can go. Okay, so now I'm going to talk a little bit about what it's like to use Docker today and some of the tools that are out there to help you. So in 2014, it seemed like Docker's priorities were getting to version 1.0 so that they could take the big red box off of all the documentation. And that happened in June of last year. After that, they were working on establishing all those partnerships, like on that slide I mentioned. And then they were rounding out some rough edges in some of those releases after 1.0. And those rough edges were really, really important to me as someone who talks and teaches about Docker a lot, because they really took care of a few of the gotchas that made it hard for people to start using Docker for the first time. So if you had tried using Docker before, but you got frustrated because something wasn't working, or maybe you were using a tutorial that was out of date or something like that, I would definitely give it a shot post version 1.3. We're on version 1.6 of Docker now. They took care of a lot of those hangups that made it frustrating to use Docker early on. So in 2015, it seems like Docker's priorities are making Docker even easier to use, rounding out more of those rough edges, keeping the API for Docker itself pretty stable. They are focusing on popularizing best practices for scaling. So if you go to the Docker DC meetups, this is like the big topic that everyone wants to learn about every time we get together, is who has actually taken Docker and put it in production and done it to do, and used Docker to do something really serious, like the core part of their business, and done it at scale. And when I was at PyCon a couple weeks ago, we did an open space of people who were running Docker in production. And unfortunately, for the most part so far, the people who were talking about using Docker in production were people who clearly were like super, like they had to figure out a lot of their own solutions to some of the problems that they encountered. And so what I'm expecting is going to happen this year is those tools that people built for themselves to solve some of these problems of running Docker at scale will get either open sourced or incorporated into other open source projects that are supposed to be helping with Docker orchestration. And hopefully we'll get some really good talks about it that spring up at different conferences and stuff like that. So Docker is definitely going to be popularizing those stories when they find them. And then the other thing that Docker is doing, which is kind of interesting, is including more batteries. And by that, what they mean is giving you all the tools as part of the official Docker toolchain to help you go from a regular software application on your development machine to your own cluster that is running all of your Dockerized software containers and doing some light orchestration for you. So one of those tools is that DockerCompose tool, which I mentioned was previously known as Fig. And then the two new ones they're working on this year are Docker Machine and Docker Swarm. And Docker Machine is essentially their tool that you can point at your development machine or point at it somewhere in the cloud, and it's going to do everything to install Docker there for you and configure it so that's ready for your containers. And then Docker Swarm is going to be their official client for spreading out your containers across multiple machines in a cluster. So they are kind of walking a tightrope of trying not to cannibalize their ecosystem. You may have read something about that, where there are some third-party open source projects for Docker orchestration that have kind of had a head start on all this. And it's pretty clear to me, having used Docker Machine and Docker Swarm, that if you are running a big business at scale, like dozens of hosts, you would definitely still want to use one of those third-party tools. But if you're just trying to get a small web app all the way into production without any hassle, then these tools are going to be what you use. So I think they're so far walking down that tightrope the right way, but we'll see how it shakes out. One service that I specifically wanted to mention to this group was Shippable. So Shippable claims to be a Docker-oriented continuous integration and continuous delivery service. So they'll do your builds, but then they'll also do those deploys for you. And if you want, they'll even deploy it on their own hosted infrastructure. So Shippable is not open source. The core of it isn't open source like Drone was, as I mentioned earlier, but they're sort of positioning themselves as the Docker continuous delivery hosted service. So I actually haven't used them myself before, but if you are looking to use Docker and continuous delivery is really important to you, they could be worth checking out. So now we're getting into the parts that make me really fired up about Docker. So one of the reasons why I like Docker so much is this idea of wiring up the container. I can deploy it anywhere, and I know it's going to behave exactly the way I want. And it opens up interesting options for exactly where anywhere is. So one of the startups that's trying to give us more options for that kind of thing is Tutim. So Tutim is based out of New York, and they are basically helping to provide cloud-agnostic hosting for your Docker containers. So the idea is you tell Tutim where to get your containers, pulling them off the Docker Hub or from their own private registry, and you tell Tutim how your containers should talk to each other. And then Tutim does, then the last thing you do is there's literally a drop-down menu that says, should we deploy this on AWS or Google's Compute Engine or Microsoft Azure? Where do you want to deploy today? And assuming you have the API keys in there for those specific services, Tutim will then go off and do all of the configuration necessary to get your stack running on that cloud. And it completely abstracts away the cloud-specific details of running your stack on each of those different providers. Which I think is really, really exciting. And it opens up some interesting ideas, which we'll talk about in a little bit. But one of the things that Tutim does is it's still creating virtual machines, traditional virtual machines, and then installing your containers on those machines. So if you point Tutim at AWS, it's going to create EC2 instances and then install your containers on those EC2 instances. But there's a new breed of hosting services that all the big computing providers are putting out there to make it easier to put your containers directly on their own infrastructure. So this is what I'm calling container-specific hosting. And Amazon's EC2 container service is the service that they're using for this, where the idea is there's not even a virtual machine component in play at all. You are just literally giving Amazon your containers, and they're wiring them up exactly the way you expect. And this slide is actually a little out of date. The Amazon Container Service got out of preview mode like a couple weeks ago. So according to Amazon, this one's ready for prime time, which is really exciting. Google has their own, which they're calling the Google Container Engine, and this one is still in alpha. I checked earlier today. And Sam was talking about getting Microsoft and continuous delivery earlier. Much like that, Microsoft does not want to be left behind when it comes to Docker. And so they are sort of pledging their own support for Docker, which they're working on right now. One thing that's going to be kind of interesting about it is that right now Docker only works on Linux. And as you would imagine, the underlying details of how that happens, the containerization technology, can't just be translated to Windows. So we won't have a situation where I could be running a Linux host and Windows containers, or Windows host and Linux containers. But what Microsoft is trying to do is create their own Windows container technology and then have that work with the same Docker API. So if you were switching between a Linux stack and a Windows stack, you'd be able to use all the same Docker commands and all the same tools in the Docker ecosystem, even though the underlying container engine would be different. So that is still, I don't even know if I've seen like a public release of an alpha on that yet. But it's something to watch if you are a Microsoft person. And so I mentioned earlier about the benefits of switching in between clouds. This was a really interesting chart that came out from RBC Capital last year, which I read about on Business Insider. It was an analysis of cloud computing costs over the course of the past year and a half. And so all the way on the left here, you can't really see it, is AWS, and then there's Google, and then Azure's over here. And the leftmost bar graph for each entry was their cost of gigabytes RAM per month at October 2013, and then the one all the way on the right is the cost in December 2014. And so AWS dropped a ton over the course of that time. It went from $42 per gigabyte RAM to $25 per gigabyte RAM over the course of that time span. And you might remember reading some headlines about all the cloud computing providers kind of starting to compete with each other a little bit more. I read a post on I forget exactly where it was, not long ago, that talked about how Amazon Web Services still possesses like 70% of the total computing power of this entire industry. So no one's about to unseat AWS, but it seems clear that Google and Microsoft are at least trying to give them a run for their money. So one of the cool things about using Docker containers, whether you're using a service like Tutim or not, is the idea that if you can make your stack work with containers, then it's a lot easier for you to change computing providers, hosting providers. And so maybe there will be a situation in the future where these guys actually start to compete with each other on price a little bit more frequently, and people are actually switching their stacks between them, with much more frequency. And it also opens up, like, I don't know, this is where I get really, I don't know if it's super futurist, but this is where I get a little in the clouds, oh, that was a bad pun. It's really cool to think about switching your stack between these providers for different reasons other than price. So one of the things that's always been funny about all these different computing providers is they kind of make it hard to compare actual computing power across them, right? They all have their own weird little metrics. Like Amazon has elastic compute units, and I don't even know if the definition of what one elastic compute unit is has changed over time, if they keep it updated or not. But it's like impossible to know what an elastic compute unit is compared to something that would actually run on a real machine in your office, right? And on top of that, you run into these problems every once in a while of maybe they just have weird network things going on in their data center that are affecting all customers, or maybe there's a situation where someone else who's running on the same host as you in the data center is doing a lot of I/O, and so they're just slamming stuff that's impacting your application in ways that you can't really measure. It's really cool to think about what could happen if it was so easy for you to switch providers that as soon as you saw some weird blip about performance or about network latency, that you could just say, okay, I would rather like at least spin up a backup stack on Azure or Compute Engine just to make sure that if things get any worse, I can just switch over my DNS and things are ready to go. So I think, I don't know, if someone else is looking for like an open source idea / business, I think that's something there. I don't know if the world is ready for it yet, but it's really cool to think about how maybe in this future, when things go down, with AWS, instead of all of us just biting our fingernails until they figure it out, we could actually just spin up our stack somewhere else, and it's crisis averted. So now that we've kind of talked a lot about what Docker is and what it lets you do, I wanted to kind of tie it back into continuous delivery and talk about why people often associate Docker with continuous delivery. So the first one is, like on that slide that I opened with, this idea of consistency between environments makes it much less likely that you're going to run into this problem of something that worked in dev blew up in production and creating this antagonism between your dev and ops teams. Part of how Docker does that is it makes sort of a cleaner separation of concerns between dev and ops. So from development's perspective, they worry about the Docker container itself wiring up everything inside it exactly the way they want, and then they hand off that fully baked Docker image to the ops team, and the ops team can figure out the best way to run it on the infrastructure that you're using. And the ops team can still use all of its regular monitoring suites because when Docker containers are running from the host's perspective, it just looks like any other process. So faster deployments is a really big one. If you have that separation of concerns and if you have that more higher level of confidence that something that worked in development is not going to blow up in production, that makes it less risky for you to take new code into production. And it makes it easier from a development lifecycle perspective, and the deployments are also faster from a just a pure time perspective because containers can start up so much faster than virtual machines. It's easier to pick the right tool for the job, and by this I mean it's easier for your organization to support different kinds of technologies all within your same business. Because these Docker containers can be wired up, and then once they're wired up, the operations team doesn't need to worry too much about what programming language is happening under the hood, and they don't have to worry too much about fixing it when it goes wrong. It makes it easier for you to support multiple different kinds of technologies in the stack that you're using. I guess I should say, like, not bulletproof, right? Sorry. Sometimes when I talk about Docker, I get really excited. This is definitely not like a silver bullet for any of these problems, but it makes it easier to solve them. And so if you have lots of different containers that are running around, and if you're free to pick the right tool for the right job, then this is how people get to the conclusion that Docker is a good fit for microservices, where your stack is broken down into much smaller, sort of independent components that maybe still rely on each other but operate independently. So boxing things up in containers makes it much easier for you to treat each of those components as the isolated entity, as the microservice that you want them to be. Okay, so we're almost to the end, but I wanted to wrap up with 5 quick tips for people if you're going to try out Docker for the first time yourself, or if you tried Docker before and you're just going to get into it again. So the first thing is that if you are thinking about how to bring Docker to your business, you should try and bring it to a non-essential service first, but bring it to each environment that service runs in. And this tip could actually be called avoid using Docker just for development. I've seen a lot of people, when they first start using Docker, they like using it just for their development environments because it makes it much easier to run that complete stack in development. But one of the weird things about Docker is that all the work you do to make your stack work with Docker and to write that Docker file for your application and to have your developers install Docker on their machine and run containers every time they're doing development on your application, it's a lot of work. And you don't really get to see the payoff of that work until you try and take that Dockerized application to the next environment. Because that's when you really get the payoff of all the work I did to create this environment for my application to run in for development. It's now the exact same environment that it's going to run in and build in production. And I don't need to do any additional configuration to get my application to run there. So I've talked to organizations where they tried using Docker just for development, and because it created more problems than it solved for them, because they weren't taking it to another environment, they eventually just got frustrated with it and gave up. Number 2 is use those official base images, like I mentioned on that slide earlier. Whether it's a programming language, or you're trying to use it for Apache or Nginx, or your database, or some sort of caching layer, there's a really good chance that someone has already built one of these official images for you. And these official images are maintained either by Docker Inc. itself, or by the open source project behind that particular image. So the Postgres one, for example, is maintained by the Postgres open source project. Same thing with the Nginx one. So you can have confidence that the way that image is configured with Nginx installed on it is the correct way that it's meant to be used. Number 3 is you should install DockerCompose right after you install Docker. DockerCompose is that tool that makes it easier to run more than one container at once and have them talk to each other. It's most of the time when I'm doing Docker for development, when I do it every day, I'm using DockerCompose to stand up my stack every morning when I come into the office of my application server, the database, the caching layer, Nginx, and then that's what I use to shut it down at the end of the day when I'm done. So for me, Docker is almost impossible to use for any real business unless you're using DockerCompose also. I would also keep an eye on Docker Machine and Docker Swarm. Those are those other 2 batteries that I mentioned Docker is working on right now. Because those 2 started off as brand new projects and not as a reincarnated Fig like DockerCompose was, they're a little bit further behind and not quite as mature. But I would say they're probably Docker Inc.'s top priorities for this year is getting those open source tools out to the public and into a stable state. So whenever I run a Docker tutorial and I'm doing a workshop, we used Docker Machine in the one I did a couple weeks ago, and it worked for the most part with a couple bugs for some people. But I'm going to do it again at O'Reilly's OSCON in July. And I fully anticipate that I'm going to be able to have students stand up their own cluster using these official tools as part of our 3-hour tutorial. And if you are looking for a tutorial to dig into Docker, I would recommend this one that I put together for PyCon a couple weeks ago. So you can see it at docker.atbaker.me. I think it's a good tutorial, but the main reason why I recommend it is because Docker moves so fast that so many tutorials that are out there on the web are just out of date right now. And so many of those are you couldn't write that. Yeah, so many of those tutorials are out of date, and Google doesn't always keep up by helping you find the best ones. So because I'm going to be giving this exact same tutorial, but an updated version at OSCON in July, you can count that at least for the next 3 months, this resource will be a good place to try digging into Docker. And that's all I have, so we can take some questions. Oh man, okay, start right here.
Yeah, the question I have for you, say Docker runs on top of Linux?
Yep, that's right.
So if I take Docker, create my image, move it to another environment that has a different Linux, will it work?
Yes, that's one of my favorite things about it is that it can, the distribution doesn't matter.
So, Linux, so as long as it's Linux, I could just take the image and execute any place.
Yep.
I'm going to hold you to that one.
Yeah, go right here.
So in tip number 1, you alluded to the friction of using Docker as a development environment. What's the best way to get around that? Because I can't Dockerize a Node application and then tell a bunch of Node developers, oh, you can't just change a file and refresh anymore because it's in this VM-like thing. And you can't necessarily mount from your computer because the dependencies are going to be different from your Mac versus your VM. So what steps can you take to sort of minimize the friction of using a containerized app for development, or would you just not bother with it until deployment?
Yeah, that's a great question. So should I be repeating these questions probably for audio purposes, do you think? Okay, cool. So the question was about using Docker for local development and making it easier, making it not cumbersome for your developers to actually iterate on what they're working on locally. And the thing you want to look into for that are Docker volumes. So Docker volumes are a feature that let you share a portion of the file system between the container and the host. And when I'm doing Django development or Node development locally, all the live reload stuff, everything still works exactly the way I expect it to. So it's, but that was one of those rough edges that I mentioned in 1.3, where before 1.3, if you were working on a Windows or a Mac, you couldn't share those volumes between the host and the container. So it's, that's something that was probably frustrating for people early on, but they've solved that problem now. Yeah, Bill.
Early on in your workflow where you're showing your development, build, and production, and how things
Yeah.
You showed that basically a GitHub or Git was the only means of getting between development and build. And I would almost think wouldn't you want to start your containerizing at more at the development phase?
You can definitely build those Docker images wherever you want. Sorry, I guess, yeah. Oh, man, I'm bad at this. The container, the question was, shouldn't you be building those containers before you get to the build phase in your process? Yeah, so that artifact that I had coming out of the build server, that Docker image, which is what you would want to take to higher environments, you can build that at any stage that you want. So you don't need to have like a build server doing it. If you were running a kind of a smaller operation or a smaller team, you could run your tests locally, say, okay, this looks good, and then use the Docker build command to just create that image and push that up wherever you need to take it. Does that answer your question?
Yeah, yeah. I just kept thinking that I felt like you had said earlier that developers, if they use Docker early on in their development and it works there, then they're guaranteed it will work further up the stream.
Mm-hmm.
And it didn't really see that in that diagram.
Good feedback. Yeah.
One of the advantages, I think, of VMs and things like AWS is the standardization they've done with networking and non-ephemeral data, EBS, things like that. And the things that I've always read about Docker that's kind of the hardest parts, and I think it's even worse than raw edges, to say it's kind of like a big problem, is what do you do about the fact that a database, you can't just spin it up, right?
Yes.
That's always got to be there. It's not just a website. Or same thing with networking, your IP addresses and then that namespace or whatever, it's got to be pretty clear, especially in some kind of production environment. What's going on with that to sort of make that easier? Because I think that's a huge difference.
Yeah. So the question was about like persistent data with Docker, and is that a problem, and how are people solving that problem?
And networking.
Yes, networking also. And yes, the answer is yes, that is definitely a problem. It's like when I was at that open space at PyCon a couple weeks ago talking to people using Docker in production, that was definitely the hardest part that people are having with it. But one of the cool things is that it's also a part that a lot of open source projects are targeting to make it easier for you. So one that was just open sourced relatively recently is called Flocker, F-L-O-C-K-E-R. And that's one where it seems like the project's sole purpose is to help you manage those parts of your stack where data needs to be persistent, but you're still using ephemeral containers for the other parts of your application. The networking stuff, so far I haven't seen anyone solve that problem other than kind of making some compromises and like either using something like HA proxy to like keep things super dynamic or just hard coding a couple IP addresses. But linking amongst containers themselves is something that Docker Machine and Docker Swarm are going to help provide for you.
What about linking Docker containers on separate machines? Like
Yes, that is something that Docker Swarm is going to help with. Yep. Yep.
Two questions. One is, how big are Docker image files? Because the way we deploy right now is pushing RPMs.
Okay.
And I imagine that since Docker got a copy of the whole OS, but it was shadowed out eventually, the image is bigger, right? Than RPM will be.
Yes, it's so the question was about how big are Docker images. Of course, it depends on what you're putting in there. But one of the things that, so yes, you're right. They contain the file system for an operating system. But one of the cool things about it is that Docker images are layered. And so when you are doing a deployment, sorry, I guess I should back up. When you're doing your first deployment, you're right that you'll need to pull down like every layer that was used to build that image from the operating system level stuff up to your source code. But then for every subsequent deployment, all it knows, it is smart enough to tell that the only layers in the images that changed were the top 2 layers that had your source code.
Actually, that's actually my second question was
Cool.
security. So if I'm borrowing things from Docker registry that already have a bunch of things installed in them, how do I know it's installed in them?
Yes, so all of the Docker, the official Docker images are built from repositories that are open source on GitHub, so that's one way you can get in and check. And in fact, they have this little feature on the Docker Hub which puts a little check mark next to repositories that they have, they say are like verified builds or something, which means that you can go and look at exactly the source code that created that image. But you're right, you hinted on another thing that is kind of tricky about using Docker, which is what if there's like a security patch that you need to get in there right now? So far, the answer seems to be if you are an especially security conscious organization, then you will probably want to build those base images yourself so that you can apply that patch as quickly as possible. Because you would be relying on like Docker or the Ubuntu people or the CentOS people to apply that patch for you.
So if you have to upgrade an image that you're based upon, you push out just that intermediate layer and then push out your other images, and it does the right thing if you rebuild the whole stack down from that base image?
Yes, but you can, when you're doing your build, you can specify if it should use a cache or if it should rebuild everything from scratch to make sure you're getting the latest stuff. Yeah. Yeah.
To configure the image, can you use some configuration tool like Chef or Ansible instead of using Docker?
Yes, you can, but most people don't so far. And part of that is because you lose those layers when your command that you're running in your Docker container is essentially like, hey, Ansible, go configure this whole thing. Docker will only keep that one, it only sees the difference of that one command as opposed to, the nicer way to build up those Docker files is to like put the stuff that you think isn't going to change very much at the top and put the stuff that you think is going to change all the time at the bottom so that it doesn't have to rework all those layers every time you rebuild. But configuration management tools definitely still have a place in a Dockerized stack. It's just they're more focused on deployment than they are on provisioning. Yes?
Does Docker recommend to run like one process per container, or can we run multiple processes
Yeah, so the question was, do you have to stick to one process per container, or can you run multiple processes within a container like a virtual machine? And the answer is that there's no technical reason why you can't. And actually my first like big open source project that I built with Docker, which was my own like take on a platform as a service, it used this base image created by the people who do Fusion Passenger. And that was a base image that was designed to run multiple processes within a container. So it's, I don't want to use the phrase like religious, but maybe philosophical difference within the Docker community of how hard you should adhere to that rule of one process per container. So I guess if you do some research on it, you'll see that for the most part, people try to stick to one process per container, but there are certainly instances where people have made exceptions and everyone agrees that was the right way to go. Does that help? Okay. Yeah.
Under the hood, if you have two containers that have the same dependency, are they both installed separately, or do they get installed once in the operating system and then both use that information?
Yeah, so the question was if you have two containers that have the same dependency, is Docker smart enough essentially to like share that dependency between them? Or I guess how would it work with multiple containers that have some similar dependencies among them? The answer is if that command in your Docker file for both of them said like run apt-get install like, I don't know, Python or something like that, Docker is definitely smart enough to know that the layers in those two images that just installed Python on the operating system did the exact same work. And so it will not duplicate that work. But when you are running containers from those two images, they'll still be two separate containers with their own complete isolated file systems. So the only sharing that happens is just keeping the image sizes smaller because it's smart enough to know that, hey, we did this operation in image A and this operation in image B, and they were the same operation. So I don't need to keep two duplicates of what installing Python looks like. But every time you run your container, each container is its full own isolated unit. Does that help?
Yeah, an analogy is like virtual
Yeah.
environment for Python, where you keep everything separate.
Yeah. I've definitely, like when I'm talking to Python people, I will compare Docker to virtualenv for sure. Yeah.
If we use like a config management tool for orchestration, how would it keep track of which hosts are in the cloud, where is the container having their something?
Yeah. So the question is, if you're using a configuration management tool to deploy your Docker stack, how do you know, or how do you keep track of like which containers are running where, right? that is the niche that these Docker orchestration projects are trying to fill. So Docker Swarm is going to be one way to do it, but when you need something bigger, there are much bigger projects out there. So if you just Google Docker orchestration, you will have the joys of entering into that whole world. Yeah.
Which platform do you recommend if you want to just try getting something up and running? So as opposed to AWS or Microsoft or Google or...
Yeah. So the question was if I just want to get something in the cloud using Docker, like for my first try. In my tutorials, I actually have people use DigitalOcean sometimes because they have a base image, or not a base image, but a VM starter image that already comes with the latest version of Docker installed, which is really handy for me. But now that Docker Machine is out there, Docker Machine essentially makes it super easy to just point it at any provider you want, and it will take care of setting up Docker in the right way for you. And it will take care of hooking up your local command line Docker client to the remote Docker daemon on that server.
Tutim or Docker Machine?
Docker Machine does all that, yeah. Yep. Yeah.
My understanding is that Docker is based off of C groups or LXC or some sort of Linux kernel feature. It doesn't work in OS X. So what OS X does is it runs a VM on VirtualBox and then runs Docker on that. In development, have you seen any problems with that?
Yes.
Probably shut down the drives and how things work.
Yeah, so that's exactly right. The question was, since Docker is Linux only, when you're running on Windows or Mac, Docker has to run inside of Linux virtual machine for your development environment, and does that cause any problems? It causes two frustrations that I've seen for people. One of them is that just when you're doing local development, your application doesn't show up in your web browser where you're used to. So when you want to look at where your Dockerized application is running on your development machine, you can't go to localhost because your virtual machine that is running your Docker daemon actually has its own IP address. So that's one of the things that's just kind of frustrating, but it's not like a persistent problem. The other thing that's kind of tricky right now is that a lot of people have had problems running projects with boot to Docker, which is the open source tool that lets you run Docker on a Mac or Windows. Projects that have lots and lots of files. Because by default, the file sharing, I guess, tool that VirtualBox uses is not very efficient for big files, or not for big files, but for large numbers of files. And I've actually seen that on a couple projects I've worked on where my source repo has like a lot of files in it that are being shared between my container and my host. Things just happen more slowly, and it is kind of frustrating. But I would be surprised if they don't figure that out soon. Let's see. Oh, okay. Is that, we're calling it?
Well, I was just going to say one more question, just because I don't want to keep everybody all night. If you want to talk to Andrew after we wrap up, let's let everybody kind of.
Okay.
We'll do one more.
Yeah, you.
You didn't talk about file system access. Is there anything specific there that we need to know?
No, for the most part, it's pretty straightforward. Yeah. Great last question. Thanks, guys. Thank you. Okay.